In general.
Like the chant.
Okay, yeah, perfect.
Every time. Let's try to think of
Yeah.
it.
Who drew those? And now.
Those are nice drawings.
So, this is going to be a ratio again. That's why we're in this section. Carson, if you don't want that fan on, you can turn it off.
Oh, that's what.
Okay? A ratio of favorable outcomes. What's that mean to you?
More than likely. Like, it has a higher chance, like it's favored. Like sports, like you're favored by like
No.
2 points.
I see what you're saying, but no, that's not what that means. What?
Outcomes, like.
Okay, so if it's a favorable outcome, the favorable outcome is what?
Like how much something.
The favorable outcome is what we're looking for. Okay, what we want. So in a jar of jelly beans, the favorable outcomes would be if we wanted to only think about the green ones, for instance. So when we picked out a handful, the favorable outcome would be the green ones compared to the however many we got in our hand, okay? Ratio of the favorable outcomes over, because remember a ratio is simply a fraction, right? Over the possible number of outcomes. Okay? So what's that mean? That means in my jelly bean scenario, it would be how many jelly beans are either in my hand or in the total. Okay? So the possible outcomes is the grand total. All right? So realistically, we're going to say capital P is equal to that ratio right there. So when we're talking about this, an outcome is just me doing whatever we're talking about. So an outcome would be me picking out a jelly bean. All right? So what's the probability that I get that green one? It would be 1 out of however many jelly beans that we had a chance on. But an outcome is me doing that however many times that I wanted to. Okay? So then we're going to talk about an event. And an event is that one simple time that we do this. So when you think about this, if I'm going to have a ratio, my answers should be where? My answers should be between what numbers? 0 and if it's a ratio, it's got to be between 0 and what? 1, right? Okay? What happens then if I have 0 as my outcome? What does that really mean? If I have 0, that the event of me getting a orange jelly bean, go even a little further.
Impossible.
Yeah. So 0 means it can't happen. So why can't it happen with my jelly beans? Because orange isn't even a color that's a possibility. So is it ever can it ever happen? No, it's 0. Okay? So what happens if when we think about our probability, we get a probability of 1? What happens then? Or what would have happened in our series of events? What? Try the other way.
It's more likely.
More likely.
It's
Gonna happen.
absolutely going to happen, right? This will happen. So with our jelly bean scenario, we would say, what's the probability of me drawing a jelly bean? Well, when I reach my hand in, I'm going to pick one out, right? So the probability is going to happen. All right? So we might have 0, we might have 1. Can I really ever have a probability that's an improper fraction when we're talking about these kind of scenarios? No. Right? Now, when you got to your odds, That's kind of what you were talking about, who's favored in the game and that kind of thing. Well, odds and probability aren't the same things. Okay? So what Nathan was talking about when you were talking about gambling and like sport games and stuff, the odds are different, and you can actually have an improper fraction with odds. If you have an improper fraction with odds, is that team going to win?
Yes.
Just about all the time. So if you're favored 7-2, that's a good chance. So Alabama was probably a improper fraction because they were so much better than everybody else. Okay.
I would know Ohio State to win, but it didn't happen.
Family just to be able to swim.
I just want Alabama to get their teeth knocked in.
All right, so a couple other things that we have. A sample space is a set of all possible outcomes. So a sample space would be, what is my possibilities in my jar of jelly beans? What colors do I have? All right, so you would name, for your sample space, you would name all the colors that are a possibility. And so then if you had one of those where you can't get that to happen, and then it comes up and asks you that question. So if orange isn't one of those possible questions, but they ask you then what's the probability of getting an orange one, that's still a part of the sample space, but it would be 0. Because I can't pick an orange one when there's none in there. Make sense? Okay? From there, they talk about these two, and I can't remember if they get into this in your book or not. Let me check real quick. Because if they don't get into this, we're not going to get into it. Oh, okay, so they do. So the next thing that they talk about is theoretical. Okay, let's spell this one right. Versus experimental. And these are both probabilities. So the difference between those two things. So theoretical probability is me just doing the problem as I would do it. So what is the probability, again, me getting red jelly beans? Well, there's 46 red jelly beans, and there's 250 total jelly beans. Okay, so my possible or favorable outcomes of getting a red one, and then however many there are. So to write this, we could say the probability of, and then we would put in whatever inside the parentheses that we actually want to talk about. So the probability of a red jelly bean is, we would know how many red ones there are, and we would know what the grand total was. Okay? And then don't forget everything that we've done so far. What should we do to this? Reduce it, because anytime that we can reduce, we want to reduce. What can I take out of both of those numbers? 2. So what do we get on top? 23 over 125.
Yeah.
Right? Okay. So what's experimental probability? Well, this is easier to explain if you open your book. So everybody open your book to page 311.
Ow.
So experimental probability is you doing an experiment, and then you're figuring out what the grand total was of getting something that you could have measured. So if I ask you, what's one of the easiest things that you could do for probability? One of the easiest examples of probability in sports is at the beginning of the game. What do? What? The coin toss, right? What's the probability of you getting heads?
50% chance.
1 out of 2, right? Or 50%. Okay? So my theoretical probability of getting heads would be 1 out of 2. But then the experimental would be, let's just say that we tallied up the number of times the coin was flipped in all of America on that one day. So Addie would get on the phone and start calling these people, and they would say heads or tails, and she would start marking them down. Notice how they did this down here on the bottom of page 311? Way on the bottom. See where it says the outcome, head or tails, and then the tally? So that's where Addie's on the phone. She's talking to these people. Every time they said head, she puts a little slash by the heads. Every time they put the tail, she puts it on the tail. So then the frequency would be how many people did we actually interview, or how many people actually did the experiment. So are we doing all high schools? Are we doing just the Catholic schools? Are we doing whatever? Are we doing our conference? Whatever it happens to be. So if we make it a little simpler, we could do it with our conference and say that there's 11 teams. So instead of their frequency being a grand total of 25, ours would have been a grand total of 11. So when you talk about experimental, you're talking about doing a simple theoretical probability of something, but a lot of number of times. And then you're actually trying to figure out the actual data from the entire experiment instead of just your one specific thing. That makes sense? So in this example down here on page 311, the experimental frequency would have been, if we were talking about the experimental of heads, how many people got, or how many times did heads come up? It would have been 14, right? And what was the grand total of how many times did we do the experiment?
25.
We did it 25, so my experimental probability would have been 14 out of 25 because that's the grand number of times we did it. My theoretical probability would have been, what's the probability of getting heads? 1 over 2. So my theoretical here for that problem would have been 1 over 2 for heads. So we would have wrote it like this. P of heads is 1 over 2. My experimental probability of heads was, well, it happened 14 times, and we did the experiment 25 times. So you see the difference? The theoretical is like the one-time deal. The experimental is taking the data of a bunch of times doing it, whether it was you doing it yourself, or like I said, the conference, or the state of Iowa, or maybe we even did the United States. Okay? And then each one of these would be your individual answer. Most of the time when you do probability, you're going to do theoretical probability. Okay? You're not going to do experimental very often. But we wanted to introduce what that means. So what are other ways of doing probability, or what other, I guess, how would you do some of these things? What other ways besides jelly beans? What other ways could you think about doing probability? Dice.
Marbles.
Dice is a good one, right? Marbles. But dice is a good one. What is the singular of dice? Cube. What if I only roll one? What is it called? A die, right? So if they say a die, it's only one. If they say dice, it's two. Okay. The other big one is cards. Okay. A deck of cards. How many cards are in a deck of cards? 52, right? How many different suits are there? 4. So if there's 52 cards and there's 4 suits, how many cards, or how many cards are in one suit?
126 cards in a deck, and then 22 in a plain deck.
There's 52 cards in a deck, and there's 4 cards, or 4 suits. How many of each suit?
13.
How much?
13.
13. 52 divided by 4. No jokers. Okay? So, when they talk about cards, what are the 4 suits in a deck of cards? Hearts and diamonds, okay? So remember all that stuff. Okay? That could be something that comes up. Alright? Why would we want to do probability? Some people would use this to maybe predict the future. In a sense, not like weird predicting the future, but like we would, if it's consistent enough, if the probability of me getting, red jelly bean again, if that probability is really high because, well, there's 250 jelly beans in our jar, and there's 190 or there's 249 red ones, is the probability of me getting a red one the next time that I choose it probably pretty high? Yeah, right? So the probability of me getting that one white one isn't probably real high unless I can look into the jar and really dig in there real good and find that white one. Okay, so we're predicting the future by using probability. Not in a weird psychic way, but just predicting the future, maybe in sales again, or how we're going to put out our production, how much we're going to put the efforts into making shorts compared to making jeans or something. All right?
I can predict the future.
Shh. Okay? Let's look at them right up here. A regular 6-sided number cube is rolled. Everybody understand what that is? That's one die, right? So if I have a 6-sided die and it's rolled, okay, what's the probability of rolling a 4 or a 5? What would we say? 2 out of 6, and then we reduce it to 1/3, okay? Suppose 2 cubes are rolled. Okay, so now we're going to have dice. We roll a pair of dice. Find the probability of rolling 2 identical numbers. Only 2? 6 12s, right? It'd be 1/2 of the time we should get it, right? Because I could have a 1 and a 1 and a 2 and a 2 and so on, right? Or look at this one. This is the one that's right in the middle of the page that we have open on page 311. Okay? So, suppose 2 numbers, find the probability of, this one says rolling an even sum. So, there's all the possibilities of matching up a pair of dice. Okay? So, if they had odd numbers, or sorry, they said even numbers, if you went through all those and the sum of them was even, you could count up all those individual spaces and put it over there. So, you might want to remember where that little chart is, so you don't have to go back and try to write out all of those. But if you notice then on the bottom, they showed you that P of an even number is 18 out of 36 or 1/2. So could I assume right away that P of an odd sum, would it be the same thing? You think so? I do too, okay? But again, that's just a probability. So, how about, turn the page. Page 312. Okay? We're right on the bottom, or towards the bottom of page 312 where it says 10 cards are numbered. See where I'm looking at?
Yeah.
Okay, 10 cards are numbered 1 through 10. And 1 card is chosen at random. Determine the probability of each outcome. Express each probability as a fraction and as a percent. Now, remember, because we're talking about a ratio, we should always have a fraction, but I can easily take that fraction and turn it into a percent by doing what?
Right.
First, I got to divide, and then what? To the right. Okay? So, when they ask you that, it's basically the same process, but you can just do it 2 different ways. So, notice in number 4 then. So, what does piece of 5 mean? It means I'm asking you, what's the chances of me getting a 5? And what would you say? 1/10, right? 1/10. How about an odd number? 1, 3, 5, 7, and 9. Okay, don't forget to reduce. So it's 1/2. Obviously 50%. How about less than 3? So when we say less than 3, does that include 3? No, it's got to be less than, right? So less than 3, what would we say? 1/5. 2 out of 10, right? 2/10 or 1/5. Exactly right. How about greater than 6?
3/10.
7, 8, 9, 10.
2/5.
4 over 10 or 2/5.
I think it dies.
You're having problems today. You know?
When does she know? Like that simple marker?
Down towards the bottom or the next section. So now we're going back to the table in example 2. So we're going back to that green and white table on the back last page. Everybody okay? You understand where I'm at? So number 8. The sum. So how many times does the sum of 2 or 6 happen in that chart? Count them out. Don't say it out loud. 2 or 6. Get an answer? You think?
I think
Or 2 or 6.
2 or 6.
Oh. I got it.
How many times did it happen?
6 times.
6 times?
Yep.
And how many possibilities did we have?
36.
36 times, so 6 over 36 turns into
1/6.
1/6. Exactly right. How many if I have an even or an odd sum?
36 and 1.
Or
5%.
1, right? It's going to happen every time. There's no way it can have a sum of 0, right? Okay? So it's got to be 100%. Agreed? Okay? So, everybody understand what we're talking about? Don't freak out about the experimental probability. We're really focusing on theoretical. There might be a couple of experimental. Those are the ones you just got to slow down and think about. But don't crush yourself about those. Okay? Questions?
Can you reduce experimental probabilities?
If I can, yes. So I'm still going to do the exact same thing. So if this would have been 15 over 25, then I could have taken 5 out of both of them. Yep. Total. All right? Questions here?
I don't think so.
So, that's it for the section.